this video, we're going to solve an initial value problem using Laplace transforms. We'll go step by step through the entire process from taking the Laplace transform to finding the inverse Laplace transform and then the final solution. Let's get started. The first step is to take the Laplace transform of both sides of the differential equation. The formulas that we're going to use are right here in this green box. Little y of t becomes capital Y of s, and then we have a similar formula for y prime and y double prime. Substituting these formulas into our differential equation gives us s squared capital Y of s minus s y of 0 minus y prime of 0 plus 3 times the quantity s capital Y of s minus little y of 0 plus 2 capital Y of s is equal to 0. In step 2, we substitute the initial conditions. These are these conditions up here. Y of 0 is equal to 1 and y prime of 0 is equal to 0 into this algebraic equation. I'll highlight the initial conditions so that we know what we're going to be substituting in. This gives us s squared capital Y of s minus s times y of 0, which is 1, minus y prime of 0, which is 0, plus 3s capital Y of s, I'm just multiplying through the 3, minus 3 times y of 0, which is 1, plus 2 times y of s is equal to 0. In the next step, we have to solve the resulting equation, that's the equation that we just found in step 2, for y of s. Here's y of s, and we need to combine all three of these. This gives us s squared plus 3s plus 2 times y of s. And then let's go ahead and let's put everything else on the right-hand side, and that's going to be s plus 3. Now we can solve for y of s. This is s plus 3, all divided by s squared plus 3s plus 2. In step 4, we need to rewrite this y of s into a form that we can invert. In other words, we need to rewrite it into a form that we can find in a Laplace transform table. To do this, we may need to factor, use partial fractions, or even complete the square. I'm going to go ahead and write down y of s again. It's s plus 3, all divided by s squared plus 3s plus 2. Since the denominator is a quadratic, what we want to do first is see if we can factor this. The numerator is going to stay the same, so we have s plus 3. And then if we look at this quadratic, we can factor it. And we can factor it as s plus 1 times s plus 2. To get this in a form that we can find in a Laplace transform table, what we need to do is separate the two linear factors that are in the denominator. To do this, we're going to use partial fractions. We're going to write this as a all divided by s plus 1 plus b all divided by s plus 2. We're then going to recombine the denominator, and we'll write it as s plus 1 times s plus 2, and then our numerator becomes a times s plus 2 plus b times s plus 1. Our denominators are the same, so now all we have to do is just equate the numerators. This gives us s plus 3 is equal to a times s plus 2 plus b times s plus 1. Now let's go ahead and let's multiply out our right-hand side. And this gives us as plus 2a plus bs plus b. And I'm going to go ahead and combine the s's. So we have an a plus b that multiplies s, and then we have a 2a plus b. To make this easier, on the left-hand side, I am going to put a 1 in front of the s. To solve this equation, we're going to set 1 equal to a plus b, and then we're going to set 3 equal to 2a plus b. We have 1 equals a plus b, and then 3 equals 2a plus b. So we have a system of 2 equations and 2 unknowns. There's a lot of ways we can solve this. I'm just going to use basic algebra to solve this, and I'm going to let b be equal to 1 minus a, and then I'm going to plug this into the second equation. So we have 3 is equal to 2a plus b, which is now 1 minus a, and this gives us a is equal to 2, and then if we plug that back up into our first equation, we have b is equal to 1 minus 2, which is minus 1. We can then say that capital Y of s is a, which we now know is 2. So we have 2 over s plus 1, and then b is negative 1, so we have minus 1, all divided by s plus 2. I am going to take this, and I'm going to bring this to our next page. In step 5, we need to take the inverse Laplace transform of y of s, because this is going to give us our solution, little y of t. Notice that both of these algebraic expressions are of the form 1 all divided by s plus a. In this first expression, a is equal to 1, and in our second expression, a is equal to 2. If we look at a Laplace transform table, we'll find the formula capital F of s is equal to 1 over s plus a. The inverse Laplace transform of this function from a table is then e to the minus at. And that's the formula we're going to use. When we use this formula, we see that the inverse Laplace transform of capital Y of s is equal to 2, that's just this constant right there, times e to the minus at, and now a is 1, so we just have minus t. And then our next constant is minus 1, so we have minus e to the minus at, a in this case is 2, so we have minus 2t. In step 6, we're just going to write the solution, and we already found that solution in step 5. Little y of t is the inverse Laplace transform of y of s, and it's the solution to our initial value problem. Y of t is 2e to the minus t minus e to the minus 2t. And there's our solution. The really nice thing about using Laplace transforms is that the initial conditions are built into the problem, so we don't end up with a C1 and C2 that we have to solve for at the end. And that's it. You now know how to solve an initial value problem using Laplace transforms. You should now be able to work through some practice problems on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.